This is Dr. Janes, and today I'm going to show you how to build a real simple high frequency oscillator flyback induction heater type circuit using 2 coils, 2 FETs, and a variable capacitor, and of course some batteries. Anyway, I just go through the steps of building it, and I'll show you the circuit diagram. And very cool device. It seems to be putting out a lot of power, very tunable, exactly what I need for my mad science experiments. Here we got a main coil here in the center and a feedback coil which goes to these FETs here. See if we can see the FETs, high frequency FETs, and there's our whole circuit right there. Very cool, huh? I'm trying to build a resonator, high frequency resonator, and I took half a lamp cord wire and soldered it onto the middle of this coil that I made, put Kapton tape around it to insulate it from a secondary coil. And here I'm going to try to solder these ends just to test this out onto the bare spots of the coil to make a resonator. We'll see how that works. Okay, this is a variable capacitor here. So here's our variable capacitor. Okay, and I just soldered these on here, test this out, and maybe I'll hook up my network analyzer and see what the resonator looks like, the frequencies. Okay. So let's take a look here. Here is our variable capacitor and our inductor. So this is the resonator, and here is our network analyzer I have hooked up to the resonator here. And let me just twiddle with the capacitor here. And you can see, oops, you know what? I have it on too sensitive of a setting, I think. Maybe I'm just touching the, yeah, I'm touching the capacitor. I'll try not to. So it looks like here, I've tuned the capacitor a little bit, and the resonant frequency is 23 megahertz. Okay, so this is kind of the range that I wanted. Let me tune it all the way up to the highest frequency setting. So it looks like it goes up to, what is that? I said at 50 megahertz. It's past 50 megahertz maybe. Oh, wait, here we go. It depends. I mean, I guess it's stray capacitance, changing the tuning of it, which is not good. So 44 megahertz is the upper end. Let me tune this capacitor to the lower end. And so that looks like about 15 megahertz on the lower end. Frequencies right there. Okay, so about 15 to 40. That's a pretty good tuning range. Okay. Get this out of the way. Oh, there we go. Okay. So we'll have to hook up some transistors to this and a feedback coil to see if we can get this thing to oscillate. Okay, I made a 4-turn second feedback coil, and we'll see if we can put these two together and maybe put some transistors on this thing. Okay, there we go. So I was able to get the feedback coil on around there. 2 wires on each side of this input here. Okay, so here is our transistor that I'm planning to use. And these transistors are good up to like over 100 megahertz. I think over 200, up to 200 megahertz, something like that. They're just outrageous. It's an MRF136. And I'm not sure if it's the best transistor for this application, but I happen to have these. So I looked up the spec sheet, and this is the drain here. These 2 tabs on either side are the source, and the gate is down here. So I'm thinking about hooking this guy up kind of like this, maybe in a vertical position, so that I can hook one side, the drain to the main coil, and then have the gate tab be sticking up so I can hook it to the feedback. And again, I'm not sure which way the feedback coil has to be because I'll do some experimenting on that, see if I can get it to oscillate. And then I may have to bias the gate also with a resistive divider to bring the level up so it's closer to turning on, so it's easier to oscillate. But anyway, I might try to solder two of these on, put one on each side, so they'll work kind of like push-pull. I think it might be easier to get it to oscillate if there's two of them, although I do prefer a minimalist design. A lot of my designs I use one transistor, but we'll see. The induction heaters, this is going to be similar to an induction heater, but with a feedback. So it'll be like a cross between the induction heater circuit and a flyback circuit, because it'll have the feedback here. And I believe the capacitance is going to be lower if you just feed the feedback coil between the two gates rather than having it go gate the ground. So we'll see. Okay, so I guess the next thing I'm going to do is I'm going to try to tin just the drains on these guys, these two transistors, and get solder on it so that I can solder it to the leads of the primary coil there. I'm trying to get solder all over this. And then I might tin this part too. That'll be easier to stick them together. Just build the circuit right onto this. That'll be a very low inductance compact circuit for this RF device. Okay, so there we go. We got the tin on that one, and I put some tin on these leads here on both sides. So I'm going to try to solder these things kind of in a vertical position like that, so the gate is up and it can be contacted with the feedback coil. And I'm going to put this side out. I think you can put a heat sink on here maybe. It's going to be easy to, well, we'll see. Looks like it's got through holes here, so maybe I can put a heat sink on there. And well, let's see if I can just get this thing soldered on. So I'll put one transistor here, and I'll put the other one here, and have the heatsink side facing outwards so I can put heat sinks on it. And we'll see if we can get this thing to oscillate. Okay, it looks like I tilt this thing on the side and try the solder. It looks like that first transistor might be on there. Wow. And I'll try to flip this coil the other way and solder the other transistor on the other side. And I almost need to jig to hold these. Whatever. This is a hack and slash time, I guess. Old-fashioned RF engineering. There we go. I think I have them both kind of soldered on. They're not exactly straight, but well, we'll try it out and see. Okay, so I think the next step is to tie the sources together. So I'm going to tin these back tabs here, since the sources are on either side of that, and just hook some wires to those. Hook them together. That'll be the negative side. Okay, so there we go. So here is the source of the transistor. And I just turn the tin it some so I can hook a wire up to it. Okay. Okay, so there we go. I have this wire hooked up to the transistor, and I'll put one on the other side, and then I'll hook them together, hopefully. And we'll see if we can get this thing to oscillate. Okay, there we go. So I believe I have the two sources tied together here, the transistors. And I think I'm going to try to just temporarily clip these feedback coils from this one to the gates, just with some clippy things, and see if it'll oscillate, because I'm not sure if it's got to be this way or backwards in order for the the coil to oscillate properly. Okay, there we go. I have these temporarily clamped on there with alligator clips. This is that feedback coil here. Up here. Okay. Maybe we'll check it out and see if it works. Okay, so I have my 12 volts worth of these batteries hooked up, the 18650s. And let's hook her up and see if it works. Look at that. It looks like it is oscillating. And the higher peak, the lower peak is about 15 megahertz. If I tune this, it looks like we are able to tune the frequency as I tune the capacitor here. Okay. It's definitely working. Very cool, look at that. But I thought it would be operating at a higher frequency. Let me try maybe reversing the feedback coil. Let's see what happens. Okay, I was just doing this quickly and it doesn't look like it's oscillating with the wires reversed. I'll switch it back. Hopefully I didn't burn out the transistors. Okay, I switched it back and it does not seem to be oscillating right anymore. Oh, there it is. A bunch of different frequencies. Wow. What is that? 24 megahertz. Looks like it's tunable still, kind of. Here. I don't know if it's just in a different mode. The coil's a little bit different. Looks like it is oscillating now. But what is that? Much lower frequency. 10 megahertz. Okay. And it is tunable with this. Wow. Okay, it jumped up to a higher mode, 14 megahertz. That's interesting. I'm going to have to fiddle with this and see. I guess it's not operating in a stable mode. 14 megahertz. Okay. So this is our completed circuit here. And so I have a main coil that's driven by our FETs here, high frequency FETs. And that's got 7 turns. And I have a feedback coil that's got 3 turns. And I feed this main coil from the center, so it's kind of balanced. So it kind of rings like this. These sides will go plus and minus in voltage. And put some heat sinks on the FETs so I don't burn them out, hopefully. And so this main coil is in parallel with this capacitor, this variable capacitor. It's a resonator. Then the feedback coil comes back to the gates of the FETs here, and I've soldered them all up. And I have 3 18650 batteries, so it's about 12 volts there. And I think the circuit's working pretty good right now. So ooh, my solder joint broke. Let me fix that. Okay, so I just fixed that solder joint there. Just need to put a little bit more solder on it. So let's test this guy out. And there we go. Look at that. We are at 9 megahertz. And as I twiddle the capacitors here, we go down to, what is that, 7.7 megahertz. And we'll keep on twisting the guys. Capacitor up to, I think it went up to about 14 megahertz. That's around 13 or so. Let's see, 13 megahertz. Okay. And again, just twist this capacitor here. We can tune the frequency around. Okay. It seems to be working pretty good. And let me just see if the FETs are getting hot. I put some heat sinks on them. And they seem to be working pretty good. So we'll just get a little bit more close up on this circuit. There is our main coils here, our feedback coil. This is a really simple circuit. I'll have to draw out the circuit diagram. Okay, so here's our full circuit diagram. So here is a 7-turn coil that I feed in the middle, so it's balanced on either side. I can oscillate, from here. Basically, this doesn't move. This point is 0 voltage, and then the voltage kind of oscillates like that. So feed it from the center here, from the 12-volt battery, which is our battery right there. And then we have a variable capacitor here. So that's the inner circuit here and the variable capacitor. And these guys form a tank circuit. So this sets the resonant frequency. And then we have a feedback coil, for 4-turn feedback coil. And it just goes into the gates of these two N-channel FETs. This is our FET here. Let's take a quick look at that. MRF 136. Okay. And so I tie the sources together and bring them to ground here. And the drains go to the two sides of the main oscillator coil go into the drains. A very, very simple circuit. It only has 2 FETs, 2 coils, and 1 tuning capacitor and a battery. I can't get much simpler than that. Okay, anyway, very cool circuit. And it seems to work pretty well. Okay, so there's our circuit operating. Very cool, huh? You can see you can tune it. The frequency's tuned. Look at that. Tune it with a variable capacitor, and you can see the peaks moving on our spectrum analyzer there. Very cool, huh? Okay, so actually, I was testing my circuit a little bit more, and I burned out some of the transistors, so I made some modifications. I made a quick mount. Took a bunch of these little alligator clips that I got off of Amazon, and I just mounted them onto the different contacts, the 3 different contacts, so I could just put the transistor in and pull it out very quickly. Just clipping onto the tabs. And it does seem to work. I was testing it, and there we go. See, we got the oscillations back. And just in case you're curious about the size of these coils, so this feedback coil is about 25 millimeters long, and the because the inductance also depends on the size of the coil. The main coil is about 39 millimeters. And let's just look at the diameters. Okay, so the diameter of the main coil is about 43, I guess, millimeters. And the bigger coil, the feedback coil, is about 56 millimeters ID. Okay. And so that's about all the specs you need to know if you wanted to build one of these. And again, it was, I think it was about 7 megahertz to 14 megahertz, and I believe I got most of this stuff off of Amazon. So I will, except for the transistors, I'm not sure if they're on there, but I'll post links to those if you're interested in taking a look at those components, and we will put this enough information hopefully that you can build this if you want to. Very cool project, good for experiments. Okay, anyway, this is Dr. Janes, and thanks for watching.